Hello everybody. So this is Kim 241 here at CSN, and we're going to do the synthesis of cyclohexene today. I'll be your host, Dr. Roger Reynolds, and our videographer is Professor James Ormer behind the camera. Thanks a lot, James. We really appreciate that. There it is. There it is. You recognize him, I'm sure. Okay, so this synthesis, this is a classic mechanism that we're going to do, and so the overall reaction is we're going to take cyclohexanol and we're going to produce cyclohexene. Ta-da! Okay, and we're going to do this with an acid. You can use usually sulfuric acid or phosphoric acid. We're going to use phosphoric acid, which is technically a weak acid, but it's a pretty strong weak acid, so we want to be careful. I'll have my goggles on as we work, and I'll keep my gloves on as we work. There's a little bit of water in here, which is really kind of pushing this back the other way. Now remember, this can be an equilibrium, okay? So we're going to drive the product here by distilling this off. As the reaction goes, we're heating it. This is going to distill off as we go, and we'll keep driving the equilibrium. And of course, we're going to produce water because we're eliminating the elements of water across here to make the double bond. So this is this pretty simple mechanism. We have this acting as a base. It's going to protonate this, and then whatever electrons were over there, we'll make the dihydrogen phosphate, and we will get a protonated alcohol. And again, this is an equilibrium. We've got our OHH, our protonated alcohol here. We have that. So we kind of have to have we have water around as a base. We also have the dihydrogen phosphate. We'll use water as our base. Why not? Okay. And again, this is an equilibrium. So we can do the arrow pushes back this way also. So we have water now acting as a base, arrow push. What am I doing? Let's do that again, huh? Holy crow. All right, there it goes. Now I know what I'm doing. I got to look at where I'm trying to get to. These electrons are going to be going into that bond. These back onto here. There's a lone pair in there. And then we'll end up with our regular extra lone pair there. And really, this is going right up into here, and that's our mechanism. It's really just a two-step mechanism. Protonation, and then we've taken this terrible leaving group, turning it into a pretty good leaving group in the form of water, and then we put this out, and we get this, here we put in acid, and it's minus H3O+. That's this protonated water coming out. Here's basically your mechanism for this reaction. We're not going to do it today, but we could do a bromine test on here. So we're going to leave that. That's just a reaction arrow. And the bromine test. And so you can figure out what the product is there and put that in your lab report as the write-up as what you would expect from this. We will be taking an IR, an IR of our product as well as our starting material, and you can compare the two. And look for the features that you would expect here, and look for any possible impurities that might show up in this the IR of our final product. Okay, so let's get to work and let's make some cyclohexene. Okay, so we're going to weigh out our cyclohexanol here. So this has been warmed up because it's actually a solid at room temperature, so it just needs a little bit of warming so we can liquefy it so it's easier to handle. Here we have a flask, and I'm using this just to hold it. And then we have this. This is fairly volatile, so we want to keep a lid on it after we weigh it. Now we're going to weigh this by difference. You could put it on here and tare it. We're just going to do it by difference. So I'm going to put this in here. And we don't really have to worry about this being dry because we're going to put it and do an aqueous workup on this. So let's see if that'll settle down. There's a nice, whoa.
A little symbol appears here when it's done.
Oh, well, when it settles out, okay.
Yeah, I noticed that.
These
right?
are, okay, There it is. So we got that. Let's take that as our tare weight. 0.8346.
No.
I'm going to stop it there. That's your tare weight.
All right.
8346 is past the decimal place. Okay, so we're supposed to put in 10 to 12 milliliters, is my understanding.
Yes.
And this is, we don't have to overly complicate this. If we think about what that is in terms of density, let's just take 0.8 as her density. And so that would mean to get 10 milliliters, it would be 8 grams I want to add to that, so that should be around 16. We'll go a little bit more, so let's get this up 16 plus 8. As an estimation, we should try and shoot for about 22 or something like that on the weight. And what exactly it is, we'll measure. But so that'll give us an idea. And it's organic chemistry. We don't have to be super exact with this 10 to 12. And whatever we get, we'll get a yield based on whatever this number is. So, that's about 1, we'll call it. And this stuff's kind of viscous, so it takes a little while to get it up into there. That looks like a couple mils on that one. So I'm guesstimating, I don't know, 5, 6 we put in so far, so maybe a couple more squirts. And then we'll just take a little measurement of it and guesstimate what that 10 to 12 would be. And like I said, I didn't look up the density exactly, but I'm estimating it's probably about 0.8 grams per milliliter. And okay, so let's see what that registers over here. I'm with a watch glass to put that on. Cap this up for a moment. Put a lid on it. Now we had the 08 there, or the 8. Okay, so that's about 10 grams. So with the density that we're not quite there yet. So let's put in another squirt. And I know I got a whole bunch of people behind me waiting to use this balance, and here I am futzing around. Now you could just get a graduated cylinder out and measure it out that way too. We're just choosing to do it this way. So we'll put another squirt in here too, a little bit more. And if we go over to 13, it won't kill the experiment. If we end up with 9, it wouldn't kill the experiment. We just use whatever we're going to get here as our basis to get our final % yield here. Okay, so let's use this one. Okay, so minus 8, we're looking at about 13 grams, which should put us about 10 mils. It looks like a lot more than 10 in there.
Yeah, I think you're probably fine.
Okay. So we got, it didn't go to the settled. It's supposed to, the little symbol shows up right here. And again, we're talking about, a 1/10 of a milligram out here. Okay, let's stop right there. 1347. 1347. 1347. 0.1347 for your final one. If you missed it, you can go back and rewind and see it again. Okay, so let's go over here and we'll assemble our distillation apparatus, and we're going to add in the phosphoric acid, and we're going to start to cook this thing and distill over our product. Okay, let's get to work. Okay, so I've taken the liberty of setting up our distillation apparatus here. So we have our lab jack with our heating mantle, and so we have the lab jack so we can lower the heating mantle. We've got this whole thing secured here with the clamp. We've got clips here. We've got our distillation head. We've got a column for condensing, and then we've got the vacuum adapter here. And we're changing the procedure a little bit in that we're going to just distill straight into our separatory funnel. And I'm going to start the water flow. So I've got the water going in the lower one, coming out the top one. And again, this hose is all kind of wants to do its own thing. And so I got this extra weight on it here, just clamped on there so we can hold it there. And again, you just want a slight flow. You don't want to overdo it, because if you turn it on too much, you can put too much pressure on these, they'll come apart. So we can see that flowing, and I've got a flow right here, if you can see that flowing right here at a nice little clip. And you should be checking that occasionally, because these lab faucets, they can vary as you go along. Now the lab said to cool this. It's been our experience that we don't need to cool. This is 85% phosphoric acid. It's considered a weak acid, but it's actually a fairly strong weak acid. So you do want to be careful as when you're handling that. Another very important thing that you can't see right now, and I actually put these in before when we teared it over there, is that there's boiling chips inside of this flask, so we prevent bumping. It's real important here that this is where this system is vented. We're about to heat it up, so we're going to create pressure, and if we don't have this vented to the air, we're going to have issues. But what I do have is I do have this little stopcock bolt. So our product is pretty volatile, so we don't want to lose our product. And so once we get this up to temperature and we start distilling, I can put this on here, and as long as the temperature stays the same, we shouldn't have any pressure buildup. And it's on here pretty loosely. It's just to keep from volatilizing back out once we collect it. So we'll put that on, and if pressure were to build up from a temperature change, it could easily blow this off before the glassware is going to get exploded all over the place. Okay, so to measure out the phosphoric acid, it's catalytic in phosphoric acid. You can figure out how many moles of this relative to the moles of our cyclohexenol, and you'll see that this is not a limiting reagent because it's a catalyst, so it gets regenerated, and you should show that in your mechanism in your lab report, how the acid gets regenerated. So it's not overly critical that it's an exact measurement, but I do have this graduated cylinder, and we're gonna fill this up 4 milliliters. It's about 3. So there's 4 milliliters. Okay. Phosphoric acid. Cap that up. Put it in a safe location over here. Now, the key is how are we going to get this into there? I'm actually going to keep using this. That goes to the bottom of it? Yes, it does. So that's good. I'm going to take off my thermometer here, and that'll be our entryway in. Okay. Now you see I'm using this hood. I'm keeping the hood down as far as I can keep it while I'm working with chemicals. You know, we pretty much know what's going to happen here. But you never know if you're going to add something and something's going to go awry, and you're going to want that blast shield in front of you. So always work with the hood as low as possible. And I'm just adding this amount. There's a little bit left in here, it's okay. This started off, it was a little bit wet. This is 85% phosphoric acid, meaning it's 15% water. So we don't have to worry about totally dry conditions here. It is a dehydration reaction, which is driven by Le Chatelier's principle. But the key here is once we get the cyclohexene generated, we're going to heat it up and distill it right over. And you should have an idea of which one's going to be the higher and lower boiling point, the hexanol or the hexene. And with hydrogen bonding in the hexanol, it should stay behind while this distills over. Okay, so we've got everything in place. I'm going to turn on my Variac. I'm going to set this at about 40 to start with. We want to keep an eye on it. This isn't water, so it's going to heat up pretty quickly. And we'll just wait for it to heat up. We should start seeing it sweating over here. I've got a nice water flow. We've got the heat going. It takes a little while. It's electric, so it's got to get generating the heat going. And we'll distill over some product. We want to make sure we don't distill this to dryness. We'll start seeing a vapor forming. That'll give us an indication that we should stop the reaction. If you never want to heat something to dryness because you'll likely crack the flask and you make a big mess, and then you got to clean that up, and who wants to do that? All right, so right now we're starting. We can look at our thermometer, and it's about 21.5, we'll call it. Okay, room temperature. Nice, pleasant room temperature. So a little bit of water flow still. Everything's good. So as this thing is rolling up, it's about 95 degrees, and we're going to stop the distillation. So we're going to turn off our variac here, and we're going to let this cool down a little bit from the 95. And we see we've collected, it's biphasic. We have the water on the bottom, the top, assuming is the organic based on densities. And so we'll let this apparatus cool off, and then we'll do the workup here. Okay, so the apparatus is cooled off now, so we're going to start disassembling this, and we're really after this critter here. What's left back in the flask, it looks kind of thick and viscous. It's kind of a yellow, amber, almost orange, brown goo that's left in there. We didn't go to dryness, and we'll deal with that cleaning it up later. The object of our affection right now is this. So now our product is pretty volatile. So we still have this cap. So we want to keep on using this cap when we can to keep our volatile product in here. This is pure product. We're not going to be diluting it with a solvent. So when we get after the drying phase, it should be all set to go. So we're going to get to our extraction phase. So let me set up the glassware and get that prepped up, and we'll get to it. All right, so we're going to do some extraction here. It says to use, I got DI water here, and this doesn't have to be super accurate, but I am going to go ahead, and it says 10 mils, so you get this up to about 10 mils. Now this is going to be, it's acidified, so it's apparently some of the acid comes over on this distillation. So I'm going to add that. If we do the water drop test, we can do it right now. Where is all that going? It's going into that bottom phase, as we would expect. Top phase is the organic. Bottom phase, we can do that by looking up the densities. And I like to keep my hand on this, flip it over, and immediately vent. And make sure, especially when we're setting up this apparatus, that this stopcock was secured. Another thing to remember too, I don't know if we've mentioned it in this lab series, that when you're done and you clean the stopcock off, these Teflon stopcocks can warp. So you want to loosen them up and store them. They can be kind of assembled, but make sure that they're loosened up, not tightened in there, because over time they will warp and then they'll start leaking, and they're actually kind of expensive. So I'm going to seal that up, give it a little shake. Okay, we're not seeing much gas evolution, so that's good. And we can give this a nice shake. And then we'll put it back on here. And we'll let that emulsion, you see there's a lot of emulsion there. We'll let that separate, give it a little bit of time. And again, when you drain it, you want to make sure that this is loose. Well, that emulsion, okay, so that looks like it's gotten out, and we're going to save this. Now, it says to discard these aqueous washings. I think it's always a good thing. It should say discard it after you've isolated your product. Just keep it off to the side, and when you get to your final cleanup, you never know if you got the right layer or the wrong layer. So here's the critical point as we get to the bottom of this, and I see that go down, and there it is. All right, that's the first wash with just plain water. I'm going to put this on here because our product is pretty volatile and it'll come out. The next wash, we're going to do 10 mils of bicarb. So I'm going to just pour this here, approximately 10 mils. There it is. Okay, so this is a base, and this is going to generate, we believe, CO2 when it reacts, because this is acidic. All right, so we'll get this in here. And we see vigorous bubbling. I'm not seeing a lot of it, but we'll find out when we shake it. Again, there's the water. We do the water drop test again, and we can see the water going straight into the, past the aqueous top layer into there. Okay, so now here, I want to make sure this is secure. I'm going to flip it over and I'm going to vent it immediately. And I can see a little bit of gas shooting out of there. Like that. And okay, we're not seeing a vigorous gas generation, so that's good. As I do this carefully, I'm keeping that bottom here, keeping that stopcock in place. Okay, so we're not getting a lot of gas coming off of here. You wouldn't expect a lot of acid to be distilling over. but we're getting a little bit. You can see how there's a lot of bubbles in this top phase, which is CO2. And when I do vent it, I can see a little bit of, there's a little bit of liquid there, and so I can see a little bit coming up. Get it nice and mixed up, vent it one more time. We'll put it right here and we'll let it rest for a little bit so the layers can separate. So you can see there's a little bit of emulsion here. It's disappearing pretty quickly. The top layer still looks a little cloudy. It's clearing up a little bit, but it's still pretty wet. So that's why it's cloudy, because there's water in there suspended. Most of the water is down here. We'll take that off, join it with the other water that we'll eventually discard. And so what am I not doing? I need to take this off, otherwise we get a pressure and it won't drain. All right, there it goes. It's coming down, coming down. So I do it quickly at first, and then I slow it down and get that last little drop by drop. And there it is. All right, and then it says to do one more wash with our DI water, our third wash. This is going to wash out the bicarb. Sometimes you do these with saturated salt solutions. We're just using pure DI water. Our final wash, going into here. Now we shouldn't have too much gas generation, but you never know. So I'm going to get this out. I'm going to cap it, I'm going to flip it, and I'm going to open it. And I can see a little bit of gas coming up. You see that little bubble coming up right there? That's the air, the gas evolving out. Could be some CO2 still left in there. And see, this whole time I've got this palm keeping pressure on that to keep it in. All right, we'll give it one more shake. And that's washed out. One more vent. Put it back here, let it rest, let that emulsion settle out. And I forgot to turn off my water. I can hear it going, so I'm going to turn off the water where it's a desert out there, so we want to save our water. So you can see these air bubbles here. We're going to let those kind of rest out. Now our top layer was really cloudy before, and through these washings, it's cleared up somewhat. There's still water dissolved in it, that's why it's cloudy. Once we get it in, we're going to drain off the water, then we're going to drain this in, and we're going to use anhydrous sodium sulfate. If it doesn't say anhydrous, it's probably the anhydrate. And you can see it's nice and powdery. So we'll use that to dry it. And that'll help clear out that cloudiness also. And we got a good emulsion. We got some bubbles on top, but we're worried more about this layer between the aqueous layer and our organic layer, which looks good. I'm going to open that up, and this is our last rinse coming out. I can go kind of fast at the beginning, and as it gets close to that bottom, I'm going to slow it down, and get that last bit. There it is. Okay. Here's our aqueous washings we're going to put off to the side, and I've got to go find a flask to put this in for our drying step. So I found a nice 50 mil. We could maybe use a 25 mil. We'll use the 50. Or actually, I'm looking at that. I think the 25 one might be better, because we don't want to have the smaller flask we use, the less we'll leave behind. Although this thing has a lot of crud in it and isn't very clean, so let's not use that. I see all the crud in there. Let's go find a clean one. I have a nice clean one here. All right, we don't have to weigh this yet, so I can take this off here, and I'm going to put this all down here. Drain it in. Our 25. So this is a decent yield, because we started off with, I don't know, 10 to 12 milliliters, and I've got, this is above the 10 milliliter. Now here, that stopcock, that will actually kind of work for a top for that. We could also use a watch glass for that. Let's get that out of the way. So now we need to do the drying step. You can use sodium sulfate. It takes a little longer. It's a little cheaper, so if you're doing an industrial scale, you might want to consider that to save some money, but we're not too interested in that. So this is just kind of eyeballing it. I'm going to just put about that much in there. And again, what we're critically looking for here is to make sure that it's not, you see some of it's clumping up. And we have, kind of think of it as the snow globe. So is that snow globey? It kind of, it gets all powdered up and dissipates, and you can see now the solution's getting real clear. So it takes some time. We want to give it some time, so we're going to sit this aside. I think it says 10 minutes in there, at least 5 minutes to 10 minutes to completely absorb the water. Do you think that's enough?
Yep.
Okay.
Good to me.
Okay, so we're going to let that rest for about 10 minutes, and we'll be right back. Okay, we're finally here. We have our nice clear product. Look at that, clear. It was all cloudy through the distillation. We washed it. Now the drying agent's taking the water out. And I'm not going to swirl it, but it does make a nice nativity scene, I want to say, a snow globe kind of effect. So we want to carefully decant that. But before we do that, let's get a weight on this flask here that we're going to put it into. I'm waiting for a little symbol here that says, there it is. So there it is, 0.3535. I like it. 3535, perfect.
5.3.
5353. 5353. Let's collect that. Yeah. Okay, so now taking that off, I'm going to carefully, if I can get my hands there, and I'm going to put that in here awkwardly so you can see it, and we're going to leave that behind. So you've heard wine. My grandfather was a winemaker, so the old bottles of wine that were left over from his winery that got bought out by eminent domain have a lot of sediment in it. So it's very common to take wine and decant it into a decanter, and the purpose was partly to air the wine, which is not what we're doing, but was to leave behind any sediment that would develop in the wine. So it's not wine sediment, tartaric acid and whatnot. And now we have our nice clear product, and we didn't put the top on it, so we don't want to put the top on it. And this is going to be tricky because it's volatilizing as we go, so it's going to be it's going to keep on losing weight as we just sit here. Oh, there it goes, 8106, 0.8106.
Okay.
Or 07, you got your choice. All right, so from that you should be able to get a nice yield. I'm going to take this, and we got a watch glass right here, so we're going to put that up. This is from earlier today, so we'll have to make sure we take care of that. We have our drying agent. This was already here, not sure why, shouldn't be. So we're going to clean our field and make sure.
Fire from the footage we got this morning.
Yeah, there you go. And that's it, but we will clean up our mess before we leave the lab, because that's what good lab workers do. And so we're going to take this, we got it capped up, and it's hard to describe. We've been trying to figure out that there's a very distinct aroma that's coming off of this cyclohexene. So it's good it's volatile, so we want to keep it nice and capped up. And let's go take an IR of this. All right.
I'm gonna actually, I haven't shown this in a video yet, so yeah, show them what it looks like.
It's in the room over. This is our instrument room here. It looks familiar. All right, we'll put our sample here.
And
Professor Ormord has us set up here with a couple salt plates ready to go. Okay, so this is a previous experiment here. It looks like there's an alcohol in there, by golly. And so we're going to start, the program's all fired up. We're going to use the same background that we have here. And so
this is cyclohexenol.
this is cyclohexenol. Oh, okay, so this is our starting material. So Professor Ormord, I guess, came in and ran this.
I did.
Okay, while we were doing the other stuff, my lab partner here came in and it ran this IR. So that's called efficiency. And so you took we don't see the CO2 peaks here, so you did take the background. So we're just going to use his background. Now again, we've been talking about this being a very volatile product. So we want to get this on there, we want to load it up, and then we want to run our scan. And since it's volatile, we might want to get a fair amount of material on here, still not just a drop or two really. Put that down, and it's got that pungent smell. Whoop, gee whiz. Still got product. We already got our yield, so we're good. Good thing we have.
I'll edit this out.
No.
Leave it in?
Either way. Somebody's got to spill something sometime. So I'm going to take this.
Oh, that lovely aroma.
Yeah, that's good. Okay, so I'm going to take this. So it's best to have your non-clumsy lab partner do this. So next time maybe I'll have Professor Ormore do that. So I'm going to take these. I'm going to let these air out in the hood next door.
Gosh. PU!
Yeah, I'll let you edit that out if you want. That's your call. It still looks like a lot of product there.
Yeah, you still got enough to work with.
We got enough. Look, it's still there, right?
Is it? Oh, it looks like it is, yeah. I would just run it.
Okay.
See what we got?
So we put a little bit there. We're going to take this and we're going to sandwich it on there. It looks nice and full. We're going to drop that right on our sample holder, right there. Notice I was touching the edges, and I have gloves on so we don't get any finger oil in there. We're going to shut that down. We're going to come over here, so we erase the last spectrum. We're going to come over here, and we don't need to collect blank. We want to collect sample. And we'll say, okay, sample is in there, ready to go. Down here, we can kind of keep our status. So it's setting up the instrument. It's set up to do 8 scans. So there you go, it's starting to count them off. I'm a very impatient person, so I always appreciate a little bit of that. Let you know where you're at. And voila. And we a little bit of oversaturation there, but I think we're fine. And it says add to window. So yeah, let's go add to window, we like it. Now if we wanted to, evaporation would get this ton up, but I think that's sufficient. We want to come in here and find our peak find, which is, you can find peaks right there, so I'm going to hit that find peaks. We're missing these little guys up here, so I'm going to click up there. If we really want to get those ones like there, we can get a couple extra. Is that good enough? We don't need this, right?
Nope.
Yeah. Okay, so that has all your peaks. Of course, we're going to print this out, include it in. You can take a screenshot of this. We're going to add it, right? What did I say? Where is that?
Replace in the far right.
Replace.
Far right.
Oh, where? Oh, way over there. Okay. Yeah, I do this every year, so it's been a while. All right, so there it is. And we'll go ahead and print this. What does it say? How many copies? We'll do 2 copies.
That sounds fine.
All right, so we'll do 2 copies, one for me and one for my lab partner here. And voila, everything's set up well. Because if it's not set up well, I generally go running to Professor Garner to help me. Or Cos Lindley, our stockroom manager. I am going to take this and I'm prepping it, so I'm just drawing it up here, making sure, and you can see it. It's hard to see through that camera. This is in microliters, and this is 10 microliter syringe, and I want a 1/10 of a micro. And I've got it's such a minuscule amount. You'd almost think there was nothing there, which is what we want. So I'm going to go in here. Once I push it down, it will activate it, and then I'm going to hit the plunger, and we'll be ready to go. So here it goes through, activate, done, right out. We'll let this thing do its magic. I'm going to make sure we get this thing closed back up because it's volatile.
I'll put a scan of these data at the end of the video.